Hi everyone, welcome to the class. Are you ready to learn the topic of relations and function? Then this video is for you. So friends, we are going to be looking at the concept by practicing very important questions on the topic relations and functions. So get ready with your pen and paper. Now let us go ahead. Here is first question. Let A is equal to set 1, 2, 3, 4. Let R be the equivalence relation on A cross A defined by AB related to CD if and only if A plus D equal to B plus C. Find the equivalence class containing ordered pair 1, 3. This is a very important question. So students, we know the what is relation. Relation means it is a subset of A cross A. We can have in A cross A, we know there will be total 16 ordered pairs will be there. So the subset of A cross A is called the relation. So here we are given one relation AB related to CD if and only if A plus D equal to B plus C. We have to select all the ordered pairs which are related to which will be related to 1 3 under this rule. From A cross A, we have to select the ordered pairs which are related to 1 3 under this rule. So uh, ordered pair 1 3 equivalence class containing 1 3 is equal to set xy. Xy means let us take this is A, this is B, this is C, this is D belongs to A cross A. All the ordered pairs must be taken from A cross A. So, such that we let us consider this is A, this is B. So what will you write? X plus D. This is A, B, C, D. So X plus 3 is equal to Y plus 1. Okay, we have to select all the ordered pairs from A cross A which is related to 1 3 under this rule. So let us simplify this. X plus 3 equal to Y plus 1. So now I will simplify it. X minus Y is equal to 1 minus 3. We select some ordered pairs from A cross A to satisfy this equation. So already we have 1 3. 1 minus 3 what? 1 minus 3 is equal to negative 2. 1 minus 3 is equal to negative 2. We select any other ordered other ordered pairs also to satisfy this equation. We have one more solution we can have 2 minus. So this is one ordered pair already given in the question. Now let us have one more is there. 2 minus 4 what? Minus 2. So let us take x2, y4. These are the two ordered pairs. That means equivalent class containing 1, 3. So the answer is, what is the answer? Answer set 1, 3 and 2, 4. Is it clear? Okay, let us take a look at the second question. A relation R in the set of real numbers R defined as R is equal to AB such that root A equal to B is a function or not. We have to check the given relation is a function or not. Students, we know that all the relations are not a function. How will you define function? Some of the relations are only functions. How can you define a function? So a function from x to y. To check a relation is function or not, we need to have two sets. We need to have two sets. Set x and set y. So function is defined all the elements. We have to check whether the relation is function or not. So all the elements in the domain, all the elements in the first component is called domain. Second component is called range. So all the x component, whatever elements are written in the first set is called a domain. Second set is called a codomain. So we have to check this is a function or not. So as per the relation, according to the question, relation is root A is equal to B. All the elements denoted by A, all the elements in the second set denoted by B. I think there are some elements in the domain does not exist. Does not exist means, do you know what is root 4 means? Root 4 you can say what? 2. Can you say root something negative 4? Do you have answer? Answer is that is not a real number. I think root a does not exist. Okay, root a does not exist for some a, not all. Some a root a does not exist. Root a does not exist for some a belongs to minus a to 0. If you put some numbers, if you put number under in the root like negative root negative 9, we don't have a real number answer. We don't have a what image. They have no image. Of course, set wise will be taken real numbers, but root negative 9 is not a real number. That is imaginary. So we can say that root a does not exist for some a belongs to negative a to 0, negative 3, negative 4, negative 5, negative 6. They don't have root exist. So we can say that all the elements of the domain have no image. So it is not a function. Clear? Okay, here is a third question. Check if the relation R in the set R of real numbers defined as R is equal to ordered by AB such that A less than B is reflexive, symmetric, transitive. We are given a relation ordered by AB such that A less than B. We have to check the given relation is reflexive or not, symmetric or not, or is it transitive. We have to check. Students, you know what is reflexive relation? What is reflexive relation? First of all, we have to check the given relation is reflexive or not. A relation R is said to a relation R in a set A is said to be reflexive if AA belongs to R for all A belongs to A. There should be one set will be given. So we take any number from that set. Then we have to check. Suppose we are taking 2, 2. As per this relation, can you say 2 less than 2? Or can you say 3 less than 3? No. So we know that this relation is not reflexive. Same number cannot. So we cannot say that by taking 2, suppose 2, 2. Suppose we are taking 2, 2. We cannot say that 2 less than 2. So we can say that it is not reflexive. So first what will you write? We have to check first reflexive or not. The given relation is let us take one A. Okay, let's take A. Here we are given set is given rational number. Set is rational number. Sorry, real number. Set is a real number. From the real number, one number we can choose. As I said earlier, suppose taking 2 or 3. So what will you write answer? Since A cannot be less than A. We cannot say that A less than A. So, what will you write? AA does not belongs to A does not belongs to R. So we say that therefore it is not reflexive. So, secondly, we have to check whether the given relation is symmetric or not. What is symmetric? Symmetric means if AB belongs to R, implies BA belongs to R. If 2, 3 belongs to R. So, suppose we are taking 2, 3. 2 less than 3, of course, correct. 2 less than 3 is correct. But can you say 3 less than 2? That is not possible. So it is not symmetric also. It is not symmetric. A less than B possible, but B less than A, it cannot be. So symmetric. To check symmetric, what you do? Let A, B belongs to R. If an ordered pair A, B belongs to R, implies what? Let us say we have chosen such an ordered pair. A less than B, okay. But it cannot be, implies it cannot be A. We cannot say that we cannot say that B less than A. B cannot be less than A. So what will you write? It is not a. So we can write that AB belongs to R implies or AB belongs to R, but BA does not belongs to R, so it is not symmetric. But now we have to check whether this relation is a transitive or not. Transitive means if AB belongs to R, BC belongs to R, we have to choose two ordered pairs satisfying this rule. We have to select two ordered pairs satisfy this rule. 2 less than 3, correct. 3 less than 4, correct. Then definitely 2 will be less than 4. So it is transitive. This relation is transitive because 3 we have transitive. We have to choose, let A, B, C belongs to R. We have to choose three numbers from the given set. What is the given set? Real numbers. So we know that if AB belongs to R, comma BC belongs to R implies AC belongs to R. So for example, if you select 2 3 belong 2, we know that 2 3 belongs to R, that means 2 less than 3, correct. Then 3 4 belongs to R. So what will you write? 3 less than 4. Definitely this is A, this is B, this is B, this is C. Definitely we will get a 2 less than 2. 2 4 belongs to R. 2 will be less than 4. So we can say that this relation is transitive. It is transitive. Next question, fourth one. Consider a function positive real numbers to 4 to infinity given by f of x equal to x square plus 4. Show that this function is a invertible function. What is invertible function? Invertible function means if a function is both 1 1 and 1 2, it is said to be invertible functions. We have to check whether the given function is 1 1 and 1 2. 1 1 function means we know that from the each element, that means in the domain set have one and only one image should be there. Suppose we have 1 2 3 4, from one element only one image, we cannot make like that. So that is not a one word like that. Then when you verify, when you prove it, how will you prove that? We have to take, let x1 x2 belongs to, two numbers should be taken from the real numbers. We are given the real numbers, positive real numbers. Okay, we have to take from, we have taken two numbers from positive real numbers. We have to verify f of x1 is equal to f of x2 implies x1 is equal to x2. Using that property, we can verify whether the given function is 1 1. Okay, now let's do that. Let x1 comma x2 belongs to R. So we will be using this property, f of x1 is equal to f of x2 implies, okay, x will be replaced by x1 square plus 4 is equal to x2 square plus 4. So 4 will be cancelled. So what will you write? X1 square is equal to x2 square. So square will be, square root will be, because since it is a positive real number, yeah, it is on 2. Okay, it is already 1 1. So x square cancel. X1 is equal to x2. So we can say that it is 1 1 function. Okay, now we have to check the given function is 1 2. If both 1 1 and 1 2, then only we can say that it is invertible function. So let us try. Let us take, so here we are given the range. What range? Domain is all the positive real numbers. Domain is all the positive real numbers, whereas the range is starting from 4 only. So what will you do? The given function we express y in terms of x. This is given y in terms of x. We try to express x in terms of y. So let y belongs to what? Y belongs to 4 to infinity. That means range. Okay, so we are given f of x is equal to x square plus 4. This is y equal to x square plus 4. Y should be expressed in, now we change the x in terms of y. So what will you write? x square is equal to y minus 4. So x is equal to root of y minus 4. I think this will be on to only. We can y will be substituted. Range, y is called range. Range is already given. So 4 minus 4 0. 5 minus 4 1. Okay, for starting from 4 we can substitute for y. So for every y we are getting x value. For every y value we are getting x value. So definitely it is onto function. For it is onto function for every y belongs to, for every y starting from 4 to infinity. Okay, our range is starting from 4 to infinity. There exists x belongs to r positive. Starting from 4 we can substitute for y. 6 minus 4 5 minus 4, 6 minus 4, 7 minus 4. For every y we are getting one x value. So we can say that it is onto functions. Being it is 1 and onto, we can say that it is invertible function. So what does it mean? Every element in the codomain have preimage. But that is the meaning onto. Onto means every element in the codomain have preimage. One means a distinct element have distinct image. So it fulfill both one and onto. So we can say that it is an invertible function. Okay, we move on to the next question. Fifth one, what is the range of the function f of x equal to mod x minus 1 by x minus 1? This is a very important question for your board exam. So we have to find the range of the given function. We know the modulus function. How will you express modulus function? It can be written like x minus 1 if x minus 1 greater than 0 or x greater than 1. Again, modulus function can be written negative value if it is x minus 1, if x minus 1 less than 0 or x less than 1. Like that we have to express the given modulus function. If it is given mod x means what will you write? Mod x equal to x if x greater than or equal to 0 or x greater than 1. Mod x equal to x if x less than 0 or x less than 1. Now we have to find the range. For all x greater than 1, how will you find the f of x value? We take x minus 1 by x minus 1, we get the range 1. Now for all x less than 1, so what is the mode function? F of x is equal to minus x minus 1 by x minus 1. So what is our answer? Minus 1. So what is our range? Range of f of x, range of the function f of x is equal to 1 and negative 1. Okay, here is our next question. Let fr to r be the function defined by f of x equal to 1 by 2 minus cos x. For all x belongs to r, find the range of f. Here we are given the function domain r, codomain r, real r to r. That is a function from r to r. Even function also given. We have to check whether we have to find the range of the function. We have to find the range of the given function. R is domain. Again, R is codomain. We have to find out the y value. Usually, this type of question when they ask, what you have to do, you always remember what is the domain of the cos function. Why we are writing domain of the cos function? This function involve cos x. Clear? This function involve cos x. So we will start with domain. What is the domain of cos function? Domain of cos function between minus 1 and plus 1. Now let us begin like this. Y is equal to 1 by 2 minus cos x. We try to, this is y in terms of x. We try to x in terms of y. We express what is, we find out what is cos x. We take the cross multiplication. Take the cross multiplication. Open, bracket open. 1, we find out the x value what? Okay. So 1 should be taken this side. So minus y become plus y. So isolate cos x one side. So we have written cos x in terms of y, that still simplify. We are getting 2 minus 1 by y is equal to cos x. We got the cos x value. So we substitute here cos x less than or equal to 1. Cos x can be substituted by 2 minus 1 by 2 minus 1 by y less than or equal to 1. We are going to find the range. So in the middle term should be only y. We should express in y itself. So we have to remove this 2 first. How will you remove this 2? Each term will be subtracting 2. Subtracted 2 from each term like that. So it becomes minus 3 less than or 2 is cancelled, minus 1 by y. Okay. Now what will happen? There is minus sign in the middle. We are going to find out only y. So each term, now we should change the sign to make it positive this. So definitely inequality will change. Inequality become greater. Okay. All negative become positive. Now still we need further simplification. This 1 by y take reciprocal. For example, 4 less than 5. When you take reciprocal, what happen? Inequality will change. Once again inequality will change. 1 by 3, okay, less than or equal to y less than or equal to 1. So what is our range? Range of the function f of x is equal to set in the set you write, okay? Set means we have closed bracket 1 by 3 to 1. This is the range of this function, okay?
Okay, now we are going to discuss seventh question. Show that the relation R on the set Z of all integers given by R is equal to order pair AB such that 2 divides A minus B is an equivalence relation or not. We have to check the given relation is an equivalence relation or not. We are given a set Z, all integers, positive, negative, all integers are supposed to take. That is the given set. Then relation is what? Ordered pair 2 divides A minus B. When you choose an ordered pair, this relation should be satisfied. Like 2 divides A minus B. A minus B must be divisible by 2. So first we check it is a reflexive or not. We know that what is reflexive relation? Reflexive relation means if A belongs to R for all A belongs to Z. Now while choosing when you choose an element that related to same element it is definitely reflexive because A minus A 5 minus 5 0 which is divisible by 2. Any integer can be taken same element 6 minus 6 minus 0 which is divisible by 2. So it is reflexive. Okay, let us prove that. First one, reflexive. Reflexive, let A belongs to Z. Okay, let A belongs to Z. We know that A belongs to Z means if A minus A is divisible by 2 means it is reflexive. Okay, A minus A is divisible by 2 means it is reflexive. So A minus A, since A minus A equal to 0, which is divisible by 2. So it is that means we can say that AB belongs to R. It is reflexive relation. Okay, it is reflexive. Now let us check symmetric, whether it is symmetric or not. How will you choose given relation is symmetric or not? That time we know that AB belongs to R implies if AB belongs to R implies BA belongs to R. So like that type of ordered pair we are going to select from the given relation. Suppose we select an ordered pair 2 divides A minus B. For example, we suppose we take 4 and 10. 4 minus 10 divisible by 2. 6 minus 4 also divisible by 2. So while proving we should take two integers A and B. A, B belongs to Z. Okay, if AB belongs to R, we select an ordered pair from the relation. AB belongs to R. What does it mean? A minus B is divisible by 2. So a minus b is divisible by 2 means definitely b minus a also divisible. So we take the common factor minus negative should be taken out, not common factor, negative should be taken out. So negative b minus a also divisible by 2. So we can say that BA belongs to R. It is symmetrical. Now third property, what is transitive? Okay, transitive. We have to check is it a transitive or not? For transitive relation, we know the property AB belongs to R and BC belongs to R implies AC belongs to R. AB belongs to R, BC belongs to R implies AC belongs to R. Suppose 4 and 12. 4 minus 12 divisible by 2. 12 and 20. It is divisible by 2. Definitely 4 and 20. 4 minus 20 will be divisible by 2. So we have to take, let A, B and C belongs to Z. Okay, A, B, C belongs to Z. If, so I will write here, if A, B belongs to R, what can you write? A minus B is divisible by 2. A minus B is divisible by 2 means what can you write? This is a multiple of A minus B divisible by 2 means it can be written 2 into 1 2k1. K1 means 1 multiple of 2's multiple. Okay, 1 const integer, 1 integer into 2. So K1 is an integer. K1 is an integer. Now BC belongs to R means what does it mean? B minus C is divisible by 2. It can be written 2 into any integer. Since it is a divisible by 2, it is a multiple of 2. 2 into any integer. K2 is an integer. K2 is an integer. Now we have to prove that AC belongs to R. So we should be adding this. This one and this should be added. Okay. A minus B plus B minus C is equal to 2K1 plus 2K2. Minus B cut. A minus C is equal to 2K1 plus K2. I think A minus difference between A and C also again it is a divisible by 2. So AB belongs to R, BC belongs to R implies AC belongs to R. What does it mean? So therefore we can write that AC belongs to R. It is transitive also. So we can say that the given relation is an equivalence relation. Okay, here is our 8th question. Let A is equal to set to 1, 2, 3, etc. 9 and R be the relation in A cross A defined by AB relative to CD if A plus D equal to B plus C for all AB and CD belongs to A cross A. Prove that it is an equivalence relation, and again we prove that also obtain the equivalence class containing 2, 5. First we have to check is it an equivalence relation or not. For equivalence relation we have to do 3 steps. You know that reflexive, symmetry, transitive. Before that make sure that when the two ordered pairs we are choosing two ordered pairs from A cross A, that is a relation. This is a relation like A, B and C, D. How it is related? A plus D, B plus C. That type of ordered pairs are in the relation. So first we have to check is it a reflexive or not. How will you check it is a reflexive or not? Normally we take an element related to the same element. So AB related to AB. We know that reflexive relation. For reflexive, we have to choose the same element. But in this case, we have to take the ordered pairs. AB related to AB. We know that AB related to AB as AB related to, since AB related to AB, AB related to AB as, how AB related to AB? A plus B equal to B plus A. For all A belongs to A. All the elements are taken from the A. For example, 2, 3, 2, 3. That means 2, 3, 2, 3 means 2 plus 3, 3 plus 2, 5. Clear? So we can say that it is reflexive. It is reflexive. Now next property we have to check symmetry. For symmetric relations, we know that we have to select two ordered pairs. AB related to CD means we have to prove CD related to AB. Let AB related to CD. AB related to CD means what can you write? AB related to CD means A plus, we can write like that as A plus D, like A and D. For here first component, here last, second set ordered by last. A plus D is equal to like that B plus C. We have to prove that AB related to CD means we have to prove CD related to AB. So we take this RHS this side by changing the order. Okay, C plus B is equal to D plus A. So we already discussed C and D. Okay, C to D, like A B C D means A to B, C to D, like that, C to D, A to B. So we know that CD, we are getting CD related to AB, that is, it is symmetric. Okay, it is symmetric. Next we have to check, is it a transitive or not. Now we have to check, is it a transitive or not. For transitive we know that we have to select three elements A, B, C, but in this case we have to select three ordered pairs A, B, C, D, E, F. Then apply this rule, property, like A plus D equal to B plus C. Now let us take AB related to let AB related to CD and CD related to EF. We have to select. Okay, we have to select A, B, C, D, E, F. So now let us check the transitive. If AB related to CD means you how will you apply write the equation, like A plus D equal to B plus C. Okay, then again if CD related to EF, if CD related to EF, what will you write? C plus F. Okay, like A plus D, B plus A plus D, B plus A, C plus F is equal to D plus E. Now AB related to CD, CD related to EF. We should prove AB related to EF. So what should be done? This A plus D, B plus C as it is, you write. Now we just change the order here. Okay. Now we have to just this can be written D plus E equal to C plus F. Now what should be done? We have to subtract this minus. Okay, A plus D minus D plus E, B plus C minus C plus F. So what we got? D is cancelled. Okay, D cancelled. We get A minus C equal to B minus F. Here C will be cancelled. Now we will be taking minus F this side, it become plus F, B plus E. So when the equation comes like that, A plus D equal to B plus C means how the ordered pairs will be formed? A and B. Okay, A and B, C and D. Like that A and B. Now we got AB related to EF. That is what we have to prove. So we understand it is transitive also. Therefore we can say that the given relation is an equivalence relation. Okay, this is the ninth question. Show that the modulus function f r to r given by f of x equal to mod x is neither 1 1 nor 1 2, where mod x is x if x is positive or 0 and mod x is negative x if x is negative. Okay, so children, this is very important question, modulus function. You know that modulus function, like modulus function always we should rewrite it as like that. Okay, modulus function means actually we write if mod x is positive x, that is given in the question itself. If x greater than or equal to 0, we should take negative x if x less than 0. We know that modulus function we write like that. It is expressed as like that. Okay. So we have a question asked to prove that this is 1 1 and neither 1 1 nor 1 2. But the relation like 2 set means f relation is R to R. This is a real number. Okay. Domain and codomain both are real numbers. Okay, so we have to prove it is a 1 1 or not. How will you prove the given function is 1 1 or not? 1 1 relation means every element in the first set have one and only one image. One and only one image. Okay, two distinct element have distinct image. That is 1 1. Is it possible in the case of modulus function? Is it possible? We know that mode negative 5 what? Positive 5. Mode positive 5 what? So I think this is not possible in this function. Same number, two different number will get a same image. So while proving, we have to choose two integers from the real number from the domain. So let us take x1 1, x2 negative 1 from the domain. Okay, so now what about x1 and x2? Both belongs to R. R means real numbers. So what is f of x1? F of x1 means 1 is equal to 1. F of x2 is what? Negative 1 is equal to, oh, I think x1 equal to, we have f of x1 and f of x1 is equal to f of x2. But x1 not equal to x2. So we understand that it is not a 1 1. So x1 and x2 are different, but f of x1 and f of x2 same. It should not come. 1 1 means every element in the domain have one and only one image, but we are getting say different elements have same image is coming. So we can prove that it is not 1 1. Now we have to prove whether it is a onto or not. How will you prove it is onto? Onto means we have to select one integer from the second set domain. Let us take let f of x is equal to this is f of x. Okay, this is x. This is f of x. Now we are checking whether it is onto or not. Onto. For onto we have to choose. Let us take f of x equal to negative 1. F of x equal to negative 1 means these all the elements in the second set codomain, what do you call? F of x. But this is not possible. F of x negative 1 means mod x is equal to negative 1. Is it possible? This is not possible, right? Mod x equal to negative 1, not possible. Which is not possible. You can verify by taking some numbers. Mod negative 5 what? Positive 5. Mod positive 5 also positive 5. Regardless of its sign, we have to write the modulus function. So this we have taken one integer from the codomain, a real number from the codomain, but that function when you substitute f of x negative 1 means mod x equal to negative 1, which is not possible. So we can say that this is not onto also. So it is this function is neither 1 1 nor 1 2. Okay. Okay, here is the last question from this topic. This is the question. Let a is equal to r minus set 3, b equal to r minus set 1 if f function a to b be defined by f of x equal to x minus 2 by x minus 3 for all x belongs to a, then show that f is bijective. What do you mean by bijective function? How will you check a function is bijective or not? I think you know what is injective function. Injective function means if a function is 1 1, if a function is 1 1, it is said to be, if a function is 1 1, it is said to be injective function. It is said to be injective function. Like that, if a function is onto, we can say it is surjective function. Okay, so if a function is both 1 1 and onto, we can say that it is bijective function. So here we are asked to check whether the given function is 1 1 and onto or not. We had to prove that they are both 1 1 and onto. We already know that How can you check a function is one function? We know that we have a property f of x1 is equal to f of x2 implies x1 equal to x2. Okay, let us verify. So we are checking whether the function is one or not. So f of x1 equal to f of x2 implies that x1 is equal to x2. So we take this function x1 minus 2, f of x1 means x1 minus 2, x1 minus 3, x2 minus 2 by x2 minus 3. So we are simplifying this and proving x1 equal to x2. Okay, so cross multiply x1 minus 2, x2 minus 3, x1 minus 3, x2 minus 2. Opening the bracket, we are opening the bracket x1 x2 minus 3 x1 minus 2 x2 plus 6 is equal to x1 x2 minus 2 x1 minus 3 x2 plus 6. So while simplifying, we are simplifying like terms, this will be cancelled. So minus 3x1 minus 2x1 become plus 2x1, like minus 2x2 minus 3x2 become plus 3x. Even 6 also cancelled. So by choosing the like terms and simplify, minus 3x1 plus 2x1 minus x1, okay, minus x1 minus x2 minus x1 plus x2 is equal to 0. So what we minus x1 minus x2 means what is x1? X1 equal to x2. So it is 1 1 function. It is 1 1 function. Now we have to, so it is subjective. It is injective. Okay, 1 1 function means it is injective. Now we have to check the subjectivity. Subjectivity means we are checking whether it is onto or not. For subjectivity, we have to take the given function f of x equal to x minus 2 by x minus 3, y is equal to x minus 2 by x minus 3. We express the function in x in terms of y. So then we can check whether y is x is defined for every y or not. So we take the do cross multiplication. Xy minus 3y x minus 2. Take the x term to LHS minus 3y. Okay, so x is common. Y minus 1 equal to 3y plus 2. So x is equal to 3y plus 2 by y minus 1. So when you check any function is onto, we always do follow this method, changing x in terms of y. So we know that this is defined for every y belongs to b. This is defined for every y belongs to b. For every y we will be getting corresponding x value, because we are given the y is actually except one, all the real values are satisfied. For every y belongs to b we are getting corresponding x value. So it is onto also. Onto means it is subjective. So this function is both injective and subjective. So it is a bijective function. It is a bijective function. So you have understood this. Okay, so students, we have discussed some very important question from this video. Hope you have understood. Make sure you revise thoroughly, practice it, take your time and revise it. So it will be really helpful to you for your board exam. Thank you.